In this video, we will discuss about inductive bias of candidate elimination algorithm. The inductive bias is also known as learning bias. The inductive bias of a learning algorithm is the set of assumptions that the learner uses to predict outputs of given inputs that it has not encountered. Before taking inductive bias, first we will discuss remarks on version spaces and candidate elimination algorithm. In that first one is, will the candidate elimination algorithm converge to the correct hypothesis? How can you say that one candidate elimination algorithm gives the correct hypothesis or not? So depending on the following two things, we can take candidate elimination algorithm gives the correct hypothesis. First one is there should not be any errors in the training examples. What are the examples you are providing to this particular candidate elimination algorithm? There should not be any errors. Second one is there is some hypothesis in H that correctly describes the target concept. Second remark is what training example should the learner request next? Learner can choose next training example from the external resources or he can take on its own. Whatever may be the resource he is taking next training example, the version space size is decreased. So version space size is reduced with each new training example. In this scenario, we have to take how many training examples are required to get the correct target concept. So that one depends on the how your version space size is reduced. If the version space size is reduced by half by taking each new example, in that case we require log vs base 2. That vs is version space size. Otherwise, we require more than log vs base 2 training examples to get the correct target concept. Third remark is how can partially learned concepts be used? So here we are taking new instances to check the you can enjoy water sport or not. And second one is the 6 hypotheses which are already generated by using candidate elimination algorithm. So you take the first instance A. So that instance is checked with the all 6 hypotheses. In this case, all 6 hypotheses gives that instance is a positive one. And next one is instance B. That instance B is compared with the all 6 hypotheses. All 6 hypotheses gives the negative result. That means those hypotheses are not taking into consideration that instance B. So now instance B is the negative one. Next instance C. So in the case of instance C, 3 hypotheses are gives the positive one and other 3 are gives the negative one. That means the half of the hypothesis gives the positive result and half hypothesis gives the negative result. So we are unable to determine whether instance C is a positive one or negative one. So that is the main drawback if you use directly the partially learned concepts. Next, if you take the instance D, that instance D is satisfied by 2 hypotheses and that one is not satisfied by the 4 hypotheses. That means 2 hypotheses gives the positive, 4 hypotheses gives the negative. In this scenario, majority vote goes to the negative. So you can take that instance D as the negative one. So out of 4 instances, A is the positive one, B is negative one, D is negative one, but we are unable to determine whether C is positive or negative. Now we will take inductive bias of candidate elimination algorithm. So in this first one is what is biased hypothesis space. See in this example, sky attribute and air temperature, humidity, wind, water forecast. So 6 attributes, and this is enjoy sport example. So to get the hypothesis, first one is so S1 is a sunny, warm, normal, strong, cool change, and S2 cloudy. For this one also, that one also positive example, and in that case only sky value is changes and remaining all attribute values are not changes. So those values are same values. So we will get as a hypothesis as that sky attribute value we are taking as the generalized one, question mark. Remaining attribute values are we are not changing. We are taking as warm, normal, strong, cool, change. So that is the hypothesis we are taking. Next, you take the third example. Third example, only sky attribute value changes. That one changes to the rainy. That one is the new one. So previously we have sunny and cloudy values are there. Now value is the rainy. Remaining attribute values are not changed. So that instance gives the negative result. How can you represent that particular instance by taking this hypothesis? It is not possible. So what is the hypothesis previously you considered? That one becomes the biased hypothesis space. Generally, we are not supposed to consider biased hypothesis in candidate elimination algorithm. So to overcome that, we have to use unbiased one. How to get the unbiased hypothesis? To get the unbiased hypothesis, we have to take power set of instances. So how to get this power set? Power set is 2 power number of instances. Okay. So in our candidate elimination algorithm example, we have 6 attributes. In those 6 attributes, sky has 3 values, air temperature 2, humidity 2, wind has 2, water has 2, forecast attribute also has 2 attributes. So total we can take 96 possible instances are present. So how to take power set of those instances? That is 2 power 96. Okay. So by considering these many instances, we can get the unbiased hypothesis. So to represent that one, we have to take disjunction of positive examples and negation of disjunction of negative examples. So for example, if you have 3 positive examples, x1, x2, x3, so those things we can represent as x1 disjunction x2, disjunction x3. If you have 2 negative examples, for example x4 and x5, so how to represent that one? Negation of x4 disjunction x5. So to get bias-free learning, first we have to take the prior assumptions for the given learning algorithm. So without prior assumptions, the target concept has no rational basis for classifying any unseen instances. So to get this one, we have to consider inductive bias. So before taking inductive bias, first we have to take the inductive inference. So what do you meant by inductive inference? So here that one is represented as a DC conjunction xi infers a learning algorithm of xi comma dc. So here L is the what is the algorithm you are using. Xi is the new instance. You have to check that instance whether that one gives the positive result or negative result. Then what is this DC? So that is the learning outcome of given examples. Learning outcome of given examples. So that DC we can take sets of x comma c of x. What is x? X is the instance, c of x is the target value. So the total d is the we can take as a sets of x comma c of x. For all the instances, what are the target values? So that DC gives the our learning outcome. So here DC conjunction of xi we can infer from L of xi comma dc, learning algorithm, new instance and dc. The inductive bias of candidate elimination algorithm is the target concept C is contained in the given hypothesis space H. So that is the inductive basis for candidate elimination algorithm. So that is represented as B. So B conjunction DC conjunction Xi. So these three, by combining these three, you are going to get the L of xi comma dc. That L is the which algorithm you are using, which learning process you are following. So L of xi comma dc is provable from B conjunction DC conjunction x of I. So that is true for all instances. So whatever the final hypothesis is you are getting, that one is true for all the instances in the given example. So now see the difference between this inductive system and theorem prover. Okay, here in the case of first one, that is directly we are taking candidate elimination algorithm. So we are training the system by using different by using training examples. If new instance is given to that particular system, so we are going to classify that one either true or false. Okay, or if you don't know that one, we are giving don't know result like this. Okay, now you come to our equivalent detective system by using the our inductive bias. Okay, so in this case we are developing the system by using training examples and we are also giving the inductive bias. So we are making that inductive bias as the explicit input. So after that, if you give the new instance, that theorem prover gives that one as the that gives the classification for that new instance or it gives the don't know condition. So then both these things are giving the same thing, classification of new instance or don't know. Then what is the main purpose, what is the main usage of this inductive bias? So if you compare with the ordinary candidate elimination algorithm with this inductive bias of candidate elimination algorithm, this inductive bias gives the more accurate result than normal candidate elimination algorithm. These are the advantages of using of inductive bias. First advantage that viewing inductive inference systems in terms of their inductive bias is that it provides a non-procedural means of characterizing their policy for generalizing beyond the observed data. So for example, if you take any problem, first you are assuming something, later you are going to derive that problem, you are going to solve that particular problem. So here also for each algorithm, first we are taking some assumptions. After that we are going to train that particular one. So this one gives the non-procedural means. Second advantage is that it allows comparison of different learners according to the strength of the inductive bias they employ. Here we are comparing three algorithms with respect to inductive bias. Those algorithms are rote learner, candidate elimination, and find-s algorithm. In the case of rote learner, if exact match is found, it returns the result. Otherwise, no result. It has no inductive bias. Next one is candidate elimination algorithm. Here, new instances are classified only in the case where all the members of current version space agree on the classification. Otherwise, the system refuses to classify the new instance. Next algorithm is find-s. It finds the most specific hypothesis consistent with the training examples. It then uses this hypothesis to classify all subsequent instances. This find-s algorithm has the even stronger inductive bias. In addition to assumption, the target concept can be described in its hypothesis space. It has an additional inductive bias assumption. So out of these three algorithms, find-s has the strongest inductive bias. Thank you.